Dear learners, in our day-to-day life, we come across many objects which are of different shapes and different sizes. Let us consider some geometrical objects. We have got here many geometrical objects. Here is a line. Let me move this line and put it over the line EF. What do we see? It does not exactly cover the line EF, but if I put it on CD, it exactly covers. That means line AB and line CD are of same shape and same size. Similarly, if I move this circle A2 and this circle moves here, put on next circle, it exactly covers the circle B2. Again let me move and put on circle C2. It does not exactly cover. Again here no question of covering. Similarly, let me move this quadrilateral and put here. They are of same shape and same size. Again put here, the shape and size are different. So we see that these objects, some are of same shape, some of different size. Figures which are of same shape and same sizes are known as congruent figures. The figures which are of same shape and same size are known as congruent figures. Now, let us discuss the congruency of two triangles. We have two triangles here, triangle ABC and triangle PQR. Let me see whether they are congruent or not. For this, let me move triangle ABC and put over the triangle PQR. We see both are of exactly same shape and same size. That means the two triangles are congruent. Now let us see their properties. Look, side AB is equal to side PQ. Next, side BC is equal to side QR. Side AC is equal to side PR. Now, let us see what about the angles. Angle A is equal to angle P. Angle B is equal to angle Q. Angle C is equal to angle R. What do we observe? We observe that if two triangles are congruent, then all the 6 parts of the triangle are same. And we say that the two triangles are congruent. The congruency of the two triangles is written like this. Here, when two triangles are congruent, we say that A is corresponding to P, angle B is corresponding to angle Q, angle C is corresponding to angle R, and the side AB is corresponding to side PQ, side AC is corresponding to side PR, and side BC is corresponding to side QR. And we say that if two triangles are congruent, then all 6 corresponding parts are same. Here we have triangle ABC. Let me construct another triangle in which side PQ is same as side AB. Angle at Q is same as angle at B. Draw line segment QR equal to the line segment BC. Join PR to complete the triangle. Now we will see whether these triangle are congruent or not. Move triangle, put over triangle PQR. What do we see? We see that both the triangles are congruent. Now look here. Just now we saw that for two triangles to be congruent, all the 6 parts should be same. But here we have considered only 3 parts, 2 sides and the included angle, and it made the 2 triangles congruent. So this rule of congruency is known as Sideangleside rule of congruency, and we write triangle PQR congruent to triangle ABC. In short, this rule is known as SAS rule of congruency. Again, let us consider a triangle ABC, and now we are considering 2 angles and 1 included side. Let me make a triangle PQR. The side QR is made equal to side BC. At point P, make the angle equal to the angle B. At point R, make the angle equal to angle C. The triangle is completed. Now, with these 3 parts equal, let us see whether the triangles are congruent or not. Look here. The triangles are congruent. So, we need only 3 parts to make the 2 triangles to be congruent. Here, the parts of the triangle used are 2 angles and the included side, and hence this is known as angle side angle rule of congruency, which is in short is written as ASA rule of congruency. Now here we have a very interesting thing. We know the sum of 3 angles of a triangle is always 180 degree. The 2 angles of these 2 triangles are same. So automatically the third angle should also be equal. That means we need not take the included side. We can take any 2 angles and 1 side. So this rule is also known as angle side rule of congruency, or in short we can call it as AAS rule of congruency. Let us discuss one more criterion for congruency of 2 triangles. This time let us consider the 3 sides of the triangle. We have triangle ABC. Let me construct another triangle PQR such that side PQ of triangle PQR is same as side AB. Side PR equal to the side AC. Side QR equal to the side BC. It completes the triangle. Now, let us see whether, considering all these 3 sides, whether the triangles are congruent or not. Again, let me move the triangle and put over the triangle PQR. See, the 2 triangles are again congruent. So, if all the 3 sides of one triangle are equal to the corresponding 3 sides of another triangle, then also the 2 triangles are congruent, and this rule of congruency is known as side, side, side rule of congruency because we considered the three sides of the triangle. And in short, we write it as SSS rule of congruency. Let us now discuss the congruency of two right-angled triangles. Let me consider a right-angled triangle ABC in which angle A is 90 degree. Construct another triangle PQR in which side PQ is equal to side AB. At point P, make angle 90 degree equal to the angle at A and draw QR equal to the side BC. Side BC is the hypotenuse of the right triangle ABC. So, here in these two triangles, we have got one right angle, one side equal and one hypotenuse of ABC equal to the hypotenuse of triangle PQR. Now let me see whether they are congruent or not. Move triangle ABC and put over PQR. They are exactly same in size and shape, so they are congruent. And here in two right angle triangles, we have considered one side equal, one right angle in both the triangles, and hypotenuse of both the triangles are same. So, this rule of congruency is known as right angle hypotenuse side rule of congruency, and we say the two triangles are congruent. And in short, we write it as RHS rule of congruency. R means right angle. So, in both the triangles, we have got one right angle. H means hypotenuse. That means hypotenuse of both the triangles are same. S means side, means one side of two right angles are same. Then these two right angles will be congruent.